welcome back. This is episode 1.3. We are going to be dealing with the scientific method today. And just as a reminder, we do have science fair projects coming up very soon, and so this particular method is going to be of importance in dealing with your science fair project. So you might want to take some good notes on this. All right, well, as with any science fair project or with any problem that you run across in just regular, ordinary, everyday life, there's got to be some kind of problem. And where did this problem come from? Hopefully you can find something around you that you have seen before, that you've always wondered about or wanted to know about how it worked or what's going on, maybe why. So a problem usually comes from some type of question or some kind of issue that you're having just in everyday life. It doesn't have to be anything, extremely chemical related or extremely scientific. That's great if it is, but it doesn't have to be. Maybe it's something as simple as your car won't start, right? Why isn't your car starting? Who knows? Well, that's where the scientific method comes in, and you actually use it all the time, and people around you use it all the time. Usually comes from some type of observation of the world around you and that you have a question about. All right, and so that leads you off into this exploration in the scientific method. All right, so there's some type of problem that you have a question about. That leads us to come up with some kind of solution. We got to be able to think of maybe why it's happening before we can fix anything. So we come up with what's called a hypothesis, and I'm pretty sure you've heard this term before in your science experiences that you had throughout your years. It's usually a belief statement as to what the problem is. It's usually phrased as an if-then. If this is changed or done, then this will happen. If the battery voltage is low, then the car won't start. Right? So it's usually phrased as an if-then statement, and a lot of times that becomes the title of our science fair projects. But most importantly, it needs to be testable. We could come up with some wacky solution and have absolutely no way of testing it available to us. So it has to be testable. All right, so once we come up with a suggestion or a hypothesis as to what's going on, then we actually have to experiment and figure it out and see if what we came up with was correct. So we get into some kind of experiment here. Now, with our car example, we'll just kind of jump right in, right? In your science fair example, you're actually going to have to write up a procedure for this, as to explain what you're going to do so that when somebody looks at your experiment, they can go back and see what you did. So a couple of terminology type things that we need to know about here. We need to know about variables. And some of you may come up with an experiment that needs a control group. Our little car battery example here doesn't really need a control group, but some may need a control group. All right, and that's the one that you kind of are comparing your experiments to see how they changed. All right, and so that leads us to our independent variable. Independent, can't spell here. Independent variables are those variables that we manipulate, that we change. And the results then show up in the dependent variable. These are our results. All right, this is what we measure. All right. And last, we have these two variables that we're dealing with here. We're changing this particular thing and looking at how it affects this particular thing, but there's usually lots of other things that can affect this one, right? So we want to keep all of those other variables constant or control them. Now don't get that confused with a control group. Maybe we're dealing with plants and we want to see the effect of fertilizer on plant growth. So we need to keep the sun, the soil, water level, all of those other things constant so that we can see how fertilizer affects plant growth. All right? And so if we have a control group, then that would be one that just is given water with no fertilizer in it. That would be our control. Our battery example here really doesn't need one, so our experiment is going to be get out a voltmeter and see what the voltage reading is on our battery. All right? So that's an important step right there, the experiment. The next step here in the scientific method is observations. What happened during the experiment? This is where we record data. Now, a lot of experiments, and we'll get into this a little bit more later, but there's different type of data that we can take. I don't want to say most important, but the critical one that we will be using are quantitative data. Root word there is quantity. All right, so these are numbers, all right, which require measurement. All right, the other type is qualitative, and that's important too, but it's a little bit more difficult to look at later. All right, in this next step, that becomes a little bit more difficult. Analysis, right? This is where we take our data and we analyze the data, right? And the best way to analyze data is through graphs, numerical data, right? Because from graphs we can see if there's some kind of relationship here, and relationships are important. That's really what we're looking for in our data. We're looking for relationships. Maybe we find out there's no relationship, but we'll talk about that here in a second. As far as our car battery example go, maybe we get out our voltmeter and it's not dead, it just has low volts. But before we can go forward, we need to know, well, how many volts are needed in a car battery to start the car? So we would have to go look that up. And once we have looked that up, then we can come to some type of conclusion, right? Is the hypothesis correct? Is it supported? Yes or no? And if it's yes, great. We can make some good conclusions then. If it's no, then we have to go back and maybe redo hypothesis. Right? So maybe in our car example here, maybe it's low volts, and so we just need to either change or charge our battery up. Right? But then we're not really done. Right? We charge up the battery. Do we know it's going to start now? No, we don't know. We have to try it again. Right? So we take a look, we make a conclusion, make a change, and then test it again. We look to see if that change was the right change or not. Okay? And so that's what you're going to kind of be, this process is what you're going to be kind of looking at in your science fair project, but it's something that you do every day, whether you realize it or not, and all kinds of professions all across the spectrum do the scientific method, whether they know it or not. Doctor diagnosing an unknown illness, finding a leak in the plumbing, finding the cause of a power failure, designing better plastic for a specific purpose, testing new medicine, and the list just goes on and on. It's just a process for how we look at things and have to try to deal with them and figure out what's going on. It's just part of our nature. Okay, so we're going to take a look in the next episode, a look at a little bit more about the measurement part and the numbers from experimenting, and so we'll be taking a look at measurement. So until then, hope you have a good one.